So we're going to read our context first. It says, the Earth's temperature increases as you move from the surface toward the center. It increases approximately 20 degrees Celsius for each kilometer beneath the Earth's surface. Okay, so I'm going to highlight increases. Okay, so what does the word increases mean?
Increases.
So, aumenta. Yeah. Can you tell me how to spell that, please?
Yes.
You just said that it goes up. That's what you said. It was increase. Okay.
So going up, right? Increasing is going up. All right. Aumenta. Thank you, Rod. All right, so it's aumenta. And so as far as math, what operation does that mean? Does it mean add, subtract, multiply, divide? What does it mean for math?
Daniel says he can't see your screen, but I can see it.
It might just need to catch up.
Okay.
Add, yes, Shanley says add. Right, so increase, you're adding. Right, and this says we add 20 degrees Celsius for each kilometer. Right. So this right here is our rate of change, right? Right. For each kilometer, we add 20 degrees Celsius. Okay. And then in our next sentence here, we're going to get some more information. We need to complete the table below showing temperature, degrees Celsius, as a function of distance beneath the Earth's surface, kilometers. It says assume the temperature on the surface is 15 degrees Celsius. When I am on the surface, how far beneath the surface am I? How many kilometers below the surface am I if I am on the surface?
I'm going to take a guess and say 0.
Yes.
Okay.
All right. So if I'm on the surface, I am 0 kilometers beneath the surface. So that means this is our start value. It is our start value here. The valor inicial. So we have a rate of change. We have our start value. Now we're ready to start filling in our table. So this sentence here, assume the temperature on the surface is 15 degrees Celsius, goes along with this first entry. Distance of 0, temperature is 15 degrees. So now I need to use my rate of change to find out the next spot, right? If I'm here, right, to the next column in the table, I've added 3 kilometers. Right. So I've added 3 kilometers. How many times do I need to add 20 degrees to 15?
¿Cuántas veces tenemos que agregarle 20 grados a los 15 grados que ya están, que ya tenemos? Si nos movemos de 0 a 3.
Yes, Anna, we have to add our rate of change, the 20 degrees, 3 times. Yes, Kevin, 3 times. So what's 3 times 20? Yes, and you say 60. Right? So we have to add 60. So 15 plus 60. Yes, Shannon, 60. Excellent. So when we use this rate of change, yes, Anthony is correct, we get 75. Then for the next one, 3 to 6 plus 3. So if I add 3 more kilometers, I add 60 more Celsius, 60 more degrees to 75. All right, what's 75 plus 60? $135. Yes, thank you, Amy. Say 135. Yes, Carlos, 135. Good job. All right. So now, each entry on my table is adding 3, right? Plus 3, plus 3. So we're adding 60, adding 60. So what are the next 2 numbers in my table? All right. Anthony's got 195 for the next one. That is correct. All right, Shanley, yes, 195 for the next one. What is the last number? Yes, Anthony, excellent. Yes, Carlos, 255. Right. Anna, yes, excellent, good job, 255. So now we've done the table. We've completed part A. Right. Yes, good job, Christian. Perfect. All right, so we have our temperature increasing as we go farther beneath the Earth's surface. So now let's look at part B. We need to write a rule using now and next that shows how the temperature changes with each additional kilometer beneath the Earth's surface. So this right here where it says each additional kilometer. Right? How many kilometers is being added based on what this says here? Each additional kilometer. How many kilometers am I adding?
Ok, vamos a escribir una regla en el que digamos el now and next, que demuestre cómo la temperatura cambia con cada kilómetro adicional que se agregue debajo de la superficie de la Tierra. Cada kilómetro adicional.
Is this asking for the rate of change for adding 3 kilometers or for adding 1 kilometer? It's a good guess, Damien. So Damien typed in y equals 3x plus 60. That's incorrect. It's a good try. I see where you got your numbers. But that's a different type of rule. I'll get back to that one. Now next doesn't use the variables. It doesn't use y or x. Okay. So let me ask this. When I add a kilometer, how many degrees do I add?
Is the answer 20?
Yes.
Okay.
Thank you, Michelle. It is 20. It's right up here, the tasa de cambio. We have 20 más por cada kilómetro. So when we get to the now next rule, next equals now plus 20 degrees. Starting at right here, what's our starting value? What's the valor inicial? $15. Yes, thank you, anything. Starting at, yes, inente, yes. Starting at 15 degrees Celsius. This now next rule shows how the temperature changes with each 1 kilometer beneath the Earth's surface. If I start at 15, yes, Shenli, thank you, and I add 20, that will tell me the temperature at 1 kilometer below the surface. If I add another 20, that's temperature at 2 kilometers below the surface. So then we get to part C, which is write a function rule relating the temperature T and distance beneath the Earth's surface D. Okay, we're being told which letter to use for the variables. Normally we would say this is X and this is Y. So instead of writing Y, we'll write T, which they already have over here. And instead of writing X, we write D. Okay, so we've been told in the problem what letter to use for a variable. Okay, and it needs to follow, so it should look like T equals some number times D, all right, plus this, and this should be the slope, or the tasa de cambio, or the rate of change. And this is the start value. Okay, so Shanley has a start. We have T equals 15 times D. But is 15 the rate of change, or is 15 the start value? Yes. So Annie, so just put it in the chat. T equals 20D plus 15. Right? That rate of change has to be attached to the thing that's making the other number change. In this case, the distance tells us what the temperature needs to be. Right? The temperature doesn't determine the distance. You said, Ms. Schutz, I didn't hear what you said.
Oh. I apologize. A nurse was in here and I was talking to her. I'm sorry.
Okay.
Okay.
Okay. So, anything is correct. We have, the rule is T equals 20D plus 15. Okay. So, right here, right, we always have the rate of change with a variable. Right. The rate of change is always with the variable.
Regla, muchachos, para recordarles, la tasa de cambio siempre tiene que ir con la variable. Porque después tenemos el más 15, que es el valor inicial. Entonces, independientemente de lo que pase con con la tasa de cambio. El 15 es el valor inicial, el 15 es la base, es lo que se le va a ir agregando a la operación que resulte del 20 por la variable que tengamos ahí.
Gracias. Okay. What questions do you have? ¿Tienes preguntas?
Nadie tiene preguntas, en serio.
Does anyone need time to write any of the notes down so far? ¿Tienes más tiempo a escribir las notas?
Okay, Kevin has questions about the first table.
Okay.
The table up there.
Okay. So, Kevin, what is your question about the table?
El valor de arriba donde dice 3, 6 y 9 es por lo que se va a multiplicar. Okay, so his question is, el valor de arriba donde dice 3, 6 y 9 es por lo que se va a multiplicar. Do we have to multiply by 3, by 6, and by 9?
In the rule, yes. So we can check our rule, right, with these values, the 3, the 6, the 9. So if I use my rule, right, and I say, okay, well, if I do 20 times 6 plus 15, this equals 120 plus 15 equals 135. This is the same, right? So the 6 is the distance from here. And when I use that to multiply by the rate of change and add the start value, I get 135 for the temperature. So yeah, you use that top value in the table to multiply by the rate of change to find the bottom value. Sorry, Mr. Morales, I had to mute you. There's a ton of noise coming from your microphone. Kevin, did that answer your question? Okay. All right. So now, Part D, we need to circle the graph that could be a graph of temperature as a function of distance. Then explain how you can pick the graph by just looking at the function rule. So which graph, 1, 2, 3, or 4, represents this rule? ¿Cuál gráfica es por la regla 20 por D más 15? Gráfica 1, gráfica 2, gráfica 3 o gráfica 4. Okay, Shanley, she says rule 2. Okay. Does rule 2 show a line that is increasing? Okay. Is gráfica 2 increasing or decreasing from left to right? We got rule 2, rule 1, rule 3. Okay, so let's do this. Which graphs show an increase? Right? ¿Cuál gráficas representar aumenta a la línea? Okay, so we have rule 1, that's showing an increase. Rule 3 shows an increase. Rule 4 shows an increase. Rule 2 is a decrease. So rule 2 does not work. Okay. Is rule 4 a line? Yes, please follow along. I know I'm getting more response to that. Eunice says it's rule 3 and she has a reason for it. Itati says it's rule 1. Well, hold on. Is rule 4 an option? Is rule 4 a line? No. Rule 4 is not a line, so it does not fit. It doesn't work, so it's not rule 4. So we have to choose a rule 1 or rule 3. So I'm going to go back in the chat to what Eunice said. She says it's rule 3 because it's the only one that is going up and doesn't start at 0. It looks like it's starting at 15. Okay, our rule starts at 15, not at 0. This is 0. Right? We can't start at 0. This graph is starting at 0. It's increasing, which is correct, but it starts too low. Graph 3 starts at a higher value and is increasing. So this fits the rule. Okay, our y value is not starting at 0. It's starting at 15. Okay, so Christian, yes, rule 3. Okay, and then Andy's explanation is good. So on the explanation, you can say graph 3 represents the function because it is the only graph that increases and doesn't start at 0. I'm going to add one other word here. It's the only line graph. Oh, same linear. More correct. Because graph 4 also increases and starts not at 0, but it's a curve. It doesn't work. And we say graph 3 represents the function because it is the only linear graph that increases and doesn't start at 0. The only one that fits what the rule is. You guys have any questions? Okay. Okay. I know, Damien, it's okay. It's all good. All right. So we're going to look at another problem. You're welcome, Michelle. I mean, you can think, and you say she came up with the explanation. I just wrote it out. It was the explanation she had. So the next problem we're going to look at is different. It's not necessarily this, it's not the same as the other problems we've seen. Okay? All right. So this problem, we're using a scatter plot, which means that we've plotted points over here that they're not exactly in a line. They're scattered. Let's see. Mr. Morales, do you know how to, or can you translate scatter? What that means?
Yes. Scatter means dispersos. Dispersos, lo que significa que están por un lado u otro.
So we have this new kind of term here, scatter plot. And in español, it is
Dispersos.
parcela de Parcela de dispersión. Right? That's the translation for scatter plot. So this here, this graph, is a scatter plot. It shows the relationship between the number of music videos sold per year and number of years since 1990. Okay. So this first at 0, 1990. The end at 13, 2003. Okay, and this is millions. Before we can use this, we need to understand the graph. So this is years since 1990. We have 1990 is 0. 2003 is 13. Okay. Have any questions so far? So now, part A. On our scatter plot at the right, draw a line that you believe is a good fit for the trend in this data. Mr. Morales, ¿cómo se dice trend en español?
Tendencia. Tendencia.
Tendencia.
Sí. The R. Tendencia.
Tendency. Okay, so it's like tendency. Okay. Okay. So here's my first question for you. Is this graph increasing or decreasing?
It looks like it's increasing, except till the very end. A little bit.
Okay. So good. So we think it's increasing, but then maybe not at the end. But when we're looking at trend, saying overall, do we expect this to go up or go down? So Shanley is saying increasing, and Anise says decreasing. Okay. Decrease. Okay. So let's do this. Let's draw a line. Okay. All right. So guys, please, I'm going to do my best on this to draw a line. Not going to be great. We're going to try. Okay, here's my line. Does this line fit the points pretty well, pretty good? It's not perfect, but does it seem close?
I think it's pretty close.
Yeah. So, I mean, and that's what it's saying. It's a good fit. Not perfect, but it's good. Right? So when we have this scatter plot, we're going to draw a line that's close. It shows if it's increasing or decreasing. So in this case, the line that we drew is increasing. Okay? So this line, it models our scatter plot. Okay, so now, the math part. Part B, we need to write a function rule that represents the line you drew in part A. This line, the line right here. We need to use N for number of years since 1990 and V for the number of music videos sold. So I need to use those two letters for my variables. Okay. So we need to find the change and the y-intercept. So one of those I start here, right? I started my graph here. So we have the y-intercept. At 0, 4. So now we need to pick a second point so that we can find our rate of change. And it doesn't need to be a point. It doesn't need to be one of these points that that's not on the line. I just need to pick a point that's on my line. So I can pick this one, right? Because this one I can see what numbers go with it easier. So this is at coordinates 9, 24. So we need to find the rate of change, or the slope, right? So let's look at the change in y first. We go up from 4 to 24. How much did we add? We go from 4 to 24. Yes, Shanley, thank you, 20. So we have an increase of y of 20. Okay. And from 0 to 9 on x, how much did we increase?
I'm going to guess 9.
9. Yes. Yes. And then we got Annie saying Shanley. Yes, 9. Thank you, Ms. Schutz. And thank you, Shanley and Annie say. We had 9. Excellent. So now remember, our rate of change, or the tasa de cambio, or the slope, all right, is the change in y divided by the change in x, which is 20 divided by 9 for this change between our 2 points, which equals 2.22 approximately. The 2 is a repeating, the 22 is a repeating decimal. It's just 2.22222222 forever. 9 and 4. Leon, ¿cuál es la 9 y 4? Leon, what's the 9 and 4 used for? Okay.
León, si quieres activar también tu audio, si nos quieres escribir para qué son la 9 y la 4, no sabes. So he doesn't know.
Okay. Okay. So we have our y-intercept, we have our rate of change, right? And now we can write the rule. Itati, I always recommend that you take notes, but these will be posted in Canvas so you can look at them again later. So we have V equals the rate of change times N. 2.22 N plus 4. Again, the 2.22, that's our tasa de cambio. And the 4 is our valor inicial. For y. Okay. Es este punto aquí. Okay. So this is how we got our rule. So we can now answer part C. It says identify the slope and y-intercept. Of the graph of your functional. Well, this is, tasa de cambio is also called the slope. I don't know why I can't write the letter P very well. And we have the y-intercept here. So for the slope, we have 2.22. Explain what each means in terms of years since 1990 and number of music videos sold. So number of music videos sold. Okay. Nice. So for the explanation, what does this part of the rule mean? It means that every year, every year since 1990, $2.22 million more music videos are sold than the previous year. So every year since 1990, 2.22 million more music videos are sold than the previous year. Okay. Mr. Morales, would you mind reading that sentence in Spanish as well?
Sí, claro. The explanation.
Yeah.
Cada año, desde el 1990, 2.22 millones adicionales de videos de música son vendidos que el año anterior.
Gracias.
De nada. Hacemos.
And then our y-intercept, the 0.04. And this means that in 1990, $4 million music videos were sold. Do I need a comma here? Yeah. Seems like I need a comma. All right. So in 1990, 4 million music videos were sold. That's what the y-intercept tells me. Okay.
De acuerdo a la intersección de Y, que es 0,4, la intersección de Y nos dice que en el año 1990, 4 millones de videos de música o videos musicales fueron vendidos. Eso considerando la información que nos da la intersección de Y.
Right. And we're not going to do part D right now. I think we've done enough. Just going to cross this out for part D. Right. We're not going to do part D today. We've done enough. Okay. What questions do you have? All right. So if there are no questions, I'm going to move on to show you what this week looks like in Canvas. Okay, so in our modules, we are in week 8. Okay, semana 8. Okay, it is Wednesday. We made it through Monday and Tuesday. Our live class resources will be updated later today, where you will be able to find the notes and the recording of the class. We have one discussion board for today. And you can have it in English or Spanish. Unfortunately, this is a picture for the table, so I couldn't. So in this, we are given 3 representations for a line. We have a context, table, and a graph. And for each one, we define the rate of change and the y-intercept and write the rule. And that's what you're going to post in your discussion. Okay, so to post, you just click reply, type in your response. Right, so say 1. Rate of change is something. And the y is something else. Rule is, you type the rule. We're going to do this for each of the 3 representations. Okay. So that's the discussion board that you should be able to do after class today. The discussion board for Friday is already ready. So you want to look at that. I'll go over it on Friday. And our one assignment this week is almost ready. It is our self-assessment. This is the first self-assessment we are going to do. And I'll go over it in more detail on Friday. But the self-assessment is one of the assignments that has the most weight towards your grade. So you have to do this assignment. If you do not do this assignment, it will hurt your grade. Okay, and I'll explain exactly what this assignment is and how to complete it on Friday. You'll have over a week to work on it. Okay.
Solo para aclarar, muchachos, que el self-assessment, dijo el maestro, de que es una evaluación que tiene más peso, que es lo que cuenta mucho más en su calificación general. Entonces el maestro va a repasar esa información con nosotros el viernes y van a tener una semana para trabajar en esa evaluación. También recuerden que la tarea es el discussion board del Wednesday de hoy, que es el slope and y-intercept. Y que ya también está disponible el del viernes, que es fuel consumption, pero eso nos lo va a explicar el maestro el viernes.